Okay, we have the zero product property at the top, just as a reminder. Let us solve x squared minus 8x plus 15 equals 0. So we can factor the left side. Earlier on in the semester, we had something like factor x squared minus 8x plus 15, and that was it. And you were asked not to set this equal to 0. And here, you're asked to set this equal to 0. The question started with an equal 0. Right? Now that we have x minus 3 times x minus 5 equal to 0, we can apply the zero product property, have x minus 3 equals 0 or x minus 5 equals 0. Please don't forget the word or. And then add 3 to both sides of the first equation, add 5 to both sides of the second equation, and we're done. X equals 3 or x equals 5. So here we use the zero product property with a equaling x minus 3 and b equaling x minus 5. So just to really point out how useful the zero product property is, it turned the more complicated equation, x minus 3 times x minus 5 equal to 0, into x minus 3 equals 0 or x minus 5 equals 0, into two smaller equations. Let's solve x squared minus 3x equals 0. Well, there's a 0 on one side. We need a product on the other side. So let's factor the left side. X times quantity x minus 3 equals 0. And so setting each factor equal to 0, x equals 0 or x minus 3 equals 0. And then we should add 3 to both sides. Apologies for the typo here. I just ran out of room. Here's the thing. Don't get visually attached to the format of x minus 3 times x minus 5 equals 0, right? So that's not the only time the zero product property applies. The zero product property also applies with a equaling just good old x and b equaling x minus 3. There's nothing in the zero product property that says that both a and b each should consist of two things or two terms or anything like that. Now let's solve x squared minus x equals 6. It is tempting to do the following. Sometimes people will factor the left side, x times quantity x minus 1 equals 6, and then we'll split this up as x equals 6 or x minus 1 equals 6, and then add 1 to both sides of one of the equations, and you have x equals 7. So x equals 6 or x equals 7, does that work? Sorry, this does not work. The thing is, if you check either x equals 6 or x equals 7 in the original equation, x squared minus x equals 6, it's not going to work out. The original left side, x squared minus x, doesn't equal the original right side when you use x equals 6 or x equals 7. So what went wrong? It was fine to factor the left side and write x times quantity x minus 1. I mean, there was no error there, but then we're actually stuck. Because you need a 0 on one side, not a 6. There's no 6 product property. Right? So we have to make sure there's a 0 on one side. And how do we achieve that? We subtract 6 on both sides. So we have x squared minus x minus 6 equals 0. The left side happens to factor x minus 3 times x plus 2 equals 0. Now apply the zero product property. You got to have a 0 to apply the zero product property. The text up in red shows somebody trying to apply the zero product property without a 0. Then take x minus 3 equals 0, add 3 to both sides. Take x plus 2 equals 0, subtract 2 on both sides. You get x equals 3 or x equals negative 2. And then, if you just wanted to check, it works out. If you check either x equals 3 or x equals negative 2, then it really turns out that the original left side of x squared minus x will in fact equal the original right side being 6. So here's the thing. Strategy. Given an equation, add or subtract terms on both sides to get one side to be a 0. Factor the other side if possible, and if factoring is successful, then apply the zero product property.